In this video, I'm going to talk about the intermediate value theorem. Suppose that f is continuous on the closed interval ab, and let m be any number between f of a and f of b where f of a is not equal to f of b. So what it means that you have a nice function, there are no holes, no jumps, no vertical asymptotes in this interval, and if you take the output value n, any output between f of a and f of b, let's see what happens. So see there's a continuous function here on ab, and here's your f of a and here's your f of b value, and if you take any value in between f of a and f of b, so let's say this is your n, then you can say that there's going to be an input, right, that gives you this output value n. So we can write here f of c equals n, and c is in the interval ab, right? So let's complete the statement of the theorem. So then we can conclude that there exists a number c in ab, in the interval ab, such that f of c is n. Okay, so that's my theorem. Whenever I have a continuous function on a closed interval, and if I take a number between f of a and f of b, where f of a is not equal to f of b, then there exists a number c in ab such that f of c equals n. And note that you might have more than one input value with the same output value. So in this case, so if you draw a function like this, right, and let's say this is my a and b, right, now you defined it on this closed interval, and that's your f of a, and this is your f of b again. But this time, if I choose my n that's closer to f of a, as you can see from my picture, I have three inputs with the same output value n. So this is c1, this is c2, and that's c3. So 1, 2, 3. So the horizontal line y equals n will cross the graph at 3 points. Okay. So we can write even f of c1 equals f of c2 equals f of c3 here, and that's all equal to n. And these values, c1, c2, and c3 in AB, right? So if we take our function, let's see another function, f of x equals square root of x in the interval 1, 9. Okay. Is square root of x continuous on 1, 9, 1 to 9? Yes, right? And we know how the graph is. So if I draw it here quickly, so it will be a nice curve like this. Let's make my x-axis a bit longer. So this is x, that's y, and I have y equals square root of x, continuous on 1 to 9. So that means that I can apply the intermediate value theorem on this closed intervals. If I pick 1, where is 1? Let's see. Let's say 1 is here, and then 9 is roughly over here. And what is the output value for x equals 9? It's going to be 3, right? So I have this one square root of 9, which is 3, and that's f of 9. Okay, and this one is the square root of 1, which is 1, so this is f of 1. So if I pick a number in between 1 and 3, between f of 1 and f of 9, then I will definitely have an input, right? Because I'm only considering the part of the graph that's between 1 to 9. So this orange part is the one I'm interested, right? So if we take any number in between, say between 1 and 3, let's take 2 easily, and then this value will correspond to a C value. And what is that? According to this function, it's going to be 4, right? And 4 is between 1 and 9. So that's what this theorem is saying. We will know that f of 4 equals 2. And why is that? Because n is between f of 1 and f of 9. Oops. Okay, so now I'm going to start talking about some problems in the next video.